So welcome to the Auction House peer-to-peer overview video. I thought I'd talk about what it is, how it works, why I think it's important, and do a bit of a demo afterwards to see it in action. So Auction House peer-to-peer or AH-P2P is a multiplayer meta-transaction auctioning system. It's designed to provide a different approach to off-chain order books that we've seen in the wild, such as OpenSea or Reservoir. The problem that it's seeking to address is some of the natural limits to scalability and the fragile trust assumptions that are starting to break under these models, really motivated by the depreciation of Reservoir on October 15th. Despite building this wonderful, incredibly efficient SaaS product, s- investing, hundreds of thousands of dollars of developers' time, they've chosen to get rid of it. And looking closely at that architecture, you can kind of see why. And so this system it offers a different approach and addresses some of the issues that they've encountered going through such a system. So currently, for those unfamiliar, in an off-chain order book for such things like NFTs, users submit off-chain signatures to some sort of centralized service that confer an intent to make a bid or an ask. Central authority collects them all and then helps facilitate users executing these offers on chain. Now, for those familiar with off-chain signatures, they don't confer any escrow or block funds from being moved. So if you're a user and you bid 1,000 tokens on something, you can just move those 1,000 tokens out of your account. They may not even exist. You can revoke the approvals on it. You can do a whole bunch of things that really block the order book from efficiently executing trades. So these services, what they wind up having to do is a process called revalidation. And revalidation operates as an indexer on the relevant contracts that checks different conditions to make sure the orders and the bids are still valid. And if they're not valid, update the state accordingly. So in the case of a bid, are the funds, so they go through the USDC contract, they start indexing USDC, do they hit the target from filter? Did the from decrease the balance below the amount of bids that they have? Did the NFT move for each NFT contract? Did the NFT move from the appropriate holder? Are the approvals still valid? On the NFT contract themselves has it been disabled? Has it been flagged? Have the tokens been burned? Has something, is it 1155? Has additional ones been minted? A lot of different conditions have to be checked to make sure each bid and each ask is valid. And you can kind of see here too, right? It's like for every single bid that exists, now they have this, continually every single block, they have to go and do something. So there's definitely an asymmetry in effort here that kind of feeds into the scalability crisis. So even before we're talking about fundamentals, they have to implement pure, like impure logic trade-offs. So kind of the question is, right, is like if you have five bids, each for 1,000, and there's only 1,000 in the account, do you invalidate four of the other bids? If so, which four? Currently in these systems, all five are left as valid until one gets utilized or some other thing breaks, like they move one token, so none of them work. So this creates a lot of false market depth. And so if you're trying to use an off-chain order book system to create valid reflections of market prices, like it's invalid depth, right? So you're going to get market inefficiencies, you're going to get mispricing. Um, these systems they have to operate faster than block speed. So maybe it wasn't as big of a problem when these systems initially started up when there was only there's only Ethereum operating in proof of work, and there's only a handful maybe of L2s. But we're in like really fast L2 land now. We're kind of going into the world of L3s, and if you cannot revalidate faster than block speed, then users can just create the bids and then immediately exit, and you have an invalid bid before you're able to revalidate. And this doesn't include also as well about minor extracted value or maximal extracted value, that if you have individuals with privileged access to the mempool and ordering of transactions, then revalidation can't really catch it at all. And so you got these problems boiling up, and then you have this single point of failure on top of it. These indexing solutions, especially when you're talking about other L2 chains, they haven't been the most robust. Speaking, it's kind of a far cry from like the 2016, 2017 days where node operation was relatively straightforward. You kind of need this magic config in the magic, domain area of a cloud server to actually have an efficient, have a node that's keeping up to the chain. Whether or not you're actually getting access to the logs at that time is a different question altogether. So if your indexing service, which is already brittle, goes down to these really retrievable things, trading stops, you're not able to perform the revalidation. So all of these, as aside from impure logic, all of these bubble up into a lot of false market depth. So we're looking for like a new system here, a system that can hopefully address some of these issues. And this is where the multiplayer meta transactions come in. So we're still doing off-chain signatures. For this case in point, we can still consider this as an off-chain order book. However, we're going to be doing some different stuff on chain. What we're going to do is that instead of just matching bids and asks atomically and then hoping they work when you submit the transaction, we're going to roll them all up into a multiplayer meta transaction, and we're going to use runtime execution in place of validation. So in the English auction case here, um, the auctioneer executes puts into the chain, sorry, a bunch of bids, highest to lowest. And it's going to check each one at runtime. So it starts with the highest. If the highest doesn't work, it moves on to the next highest until it gets a valid swap. And once the swap returns true, and then the contract concludes. So we kind of avoid a lot of this revalidation logic, just with this sort of multiplayer meta transaction format. Now this can integrate and substitute for things like Seaport right away. For the hackathon project, though, I always like exploring, even though uh, the market justification maybe isn't quite there, about doing, decentralized order books and peer-to-peer auction houses. So here we're going to use IPFS PubSub and WebRTC alongside OrbitDB. Um, so we can get browser to browser communication and through the auctioning of service or of NFTs, sorry. So kind of like we can do a quick comparison between traditional order books and what we can have here. We see this ON revalidation cost having to constantly re-index or constantly index the chain, increasing the amount of filters that you have for each bid that kind of exists on your order book. We see the centralized indexing being replaced with just a peer-to-peer network with runtime validation. Yeah, we forego the constant need for monitoring, so we can just submit it to the blockchain and it just does its best. The single point of failure is removed for a mesh network. And this part's a bit more nuanced. Some of them require a protocol fee. Some of them require executing a gas. This is gasless for the bidder, where the auctioneer incurs a gas fee. So yeah, just as a sort of technical diagram about what we see as the auctioneer creates a message, bidders attach their bids towards that message. The auctioneer has this whole kind of signature snowball. They sign the snowball and then they submit that snowball to the auction contract, which finds the highest valid bid. So yeah, and as on top of that, with the peer-to-peer kind of real-time networking, you kind of get this really kind of live auction house. You can kind of see this kind of system exist in kind of like a Decentraland where you can actually make like an auction dynamic with everyone submitting signatures through there. So yeah, so that's at a high level what auction house peer-to-peer is about, how it works, and why I think it's important. So with that being said, let's move on to the demo. Now let's do a bit of a demo that shows how the auction system works. So a user, when they go to the site, we just have a static site here behind a DNS record. There's nothing special going on. There's no backend. So if you want to run it off of a local host, it's totally fine. What we do need, though, to facilitate the initial connection between peers is a WebRTC stun intern server. The browser-to-browser connection will work fine once it's initiated, but you do need this to facilitate the initial connection and to find each other. So we're using libp2p to facilitate the networking. And there's a database persistence layer called OrbitDB that works off of that, that uses the index DB on each browser to replicate the most recent data between the peers. So it's pretty handy for an auction system like this. So yeah, so to begin, user will see the security notice. We use the Ethereum cryptography to establish an identity on the peer-to-peer network, which is handy to know that one peer belongs to which wallet address. We do have to sign two signatures here right now. It probably can get down to one, but just for ease of use, we'll also be signing a second signature that confers the identity on the Orbit DB. So we connect the wallet. They'll ask for that first signature. Orbit DB, unfortunately, is still using the old version of sign type data, so we have to sign this gobbledygook. That's not the most comfy, but there it is. We can still go ahead and sign other peers as well. I'm using Chrome, Chromium, and Brave for this. Chrome works really well out of the box. Chromium, you need to modify the WebRTC config to get it working. Brave's been pretty good so far. Firefox though has been a mixed bag. And I haven't tried Safari. But here we are. All our peers are now connected to the auction house. You see this kind of a live auctions view and a create auctions button. We do have some faucets here, so you don't have to, do anything fancy or have to worry about setting up certain NFTs and certain crypto projects. We'll use this one as the auctioneer. It has like 6 NFTs. This one will be, you can see it has a balance of 1,004 on it. Um, we use this one as the legitimate bidder. And this one, it has no tokens. We use this one as the one that pretends to create a bid. So here as the auctioneer, I will go here and create an auction. Just give it its parameters. We just pre-fill the faucet parameters as well, just for quickness and ease of use. So when you create an auction, we sign this off-chain message called the auction auth signature. It has the parameters, which NFT, which contract address, which token they want to bid, what the starting bid price is, and when the auction is set to end. And when we click that, it creates an OrbitDB database, propagates it throughout the network so anyone can see it. So we can go ahead, we can quote unquote join the battle. Thanks, Claude, for the wonderful design work. Just like that. And so we see now that the peers are connected over WebRTC, we don't actually need this done in turn server anymore. So just to illustrate how this is peer-to-peer networking, we're going to shut the relay down, and we can still see that each of the peer is still connected with WebRTC connections through libp2p. Yeah, so to begin kind of like the auction, we can see here that as a real user, they have 1,004 tokens. They have the approval set. We can use, gasless approvals, but just for simplicity, we just have the on-chain approvals here going. And if you want to create a bid, we go over to the bid tab and say, hey, I bid one. And so when we execute a bid, this too is an off-chain signature, contains the amount, and this does provide an authorization for the contract to move the funds. So we propagate this bid throughout the network. It says, hey, there's been a bid placed by which Ethereum address. Well, we can go over here and we can say, hey, we're kind of like this false kind of like griefing user. We don't have any tokens. We don't have any approvals, but we're going to go ahead and we're going to go bid it anyways. So they too are going to sign the off-chain signature to config 2 tokens. And so once the auctioneer's happy or near completion, they go once, twice, 3 times, and they go hit the consume auction button. And so with this one too, we're going to start by signing yet another signature. This auction signature, it takes the auth and auction auth signature. It takes all the bids and it wraps it into this one multiplayer meta transaction. So we sign that, and this is what we submit to the chain. So when we click confirm here, it's going to start looping over all the bids from highest to lowest. It's going to see this two. It's going to say, oh, I don't actually have tokens. So it's going to go down to the next highest. And once we see that this one is valid, it says, okay, great. The auction is complete. And I'm not sure if there's balance fetching. It looks like it did. So it has 2 token balance now, and now it's 1,003 from 1,004. So it facilitated users placing bids on an ask, or here being the English auction format, demonstrating the power of the multiplayer meta transaction system over IPFS pub sub with that WebRTC.